This map interpretation exercise is about interpreting faults and strata as displayed on a geological map. It's a great exercise that I've developed from one that was originally put together by Derek Powell, probably 30 years ago now, but it's still a really wonderful exercise. It shows a map. Our mission is to draw a cross section, and in this we're going to be aided by not only the map pattern but also three boreholes which give us some information about what happens at depth. So what we'll need is a selection of coloured crayons so we can keep tabs on the various rock units. We'll need a protractor to replot some of the dip information that we've got on the map and the boreholes, and a strip of paper so that we can transfer the information from the map to the profile. Okay, let's get going. So let's get an overview of the map. First of all, we can see that the various geological units are coloured up, and there's a key which gives us the stratigraphic order. But on the map itself there's no topographic contours, but there are these rivers that come wandering across that tell us where the valleys are. And there's also the orientation of bedding given by these symbols here. Well, if we put these two pieces of information together, we can get the dip direction. So down in here we can see these dips are off this way towards the northeast, and we can see that the V in the valley confirms that general orientation of bedding and the stratal boundaries in here. But there are also faults that come wandering around, and rather curiously they have these sort of cuspate map patterns. But we can also see that in detail these faults also V in the valleys, which gives us the dip direction. So in this particular location here, the fault is clearly dipping down towards the southwest corner, and that looks to be the same situation for the faults here and here. So we can begin to use this information to build up a cross section. And in that regard we've also got some subsurface information by these three boreholes, which are represented by these logs here. And not only does that tell us where the different rock units are at depth, it also gives fault and also shows the orientation not only of the faults but also of the strata. So we can combine the subsurface information and the map pattern to construct a cross section. Well, let's start off by putting on the faults. So we can measure where these are from the map. I'm just going to tie myself to the two wells, B and C, and put fault X and fault Y, X and Y, onto the profile below. So I'll just line this back up again. There's B and C, tie it on. So that's where fault X ties onto the map, and there's where fault Y ties from the map onto the cross section. Now we'll do these in turn, because I can see that borehole B here has a fault just in the subsurface, somewhere around here, but I also know that this fault here dips this way, so we'd expect to see it in the borehole. So presumably the fault we see at outcrop, the one I just called X, is the same one as we see in the well. So I'll just put this one and call it X. So where is that with depth? Well, it's at a depth of 1175, which would put it about there in the well. But we can also see that the fault at this position has got a dip of 42 degrees. So let's just get the protractor and put the fault on at 42 degrees. Just line it up like that, something like this. It's about 42. There we go. So that's where the fault is in the well. But to get it up to outcrop, it must steepen as it gets to the shallow areas, something like this. So the fault is curved slightly in that position. But where does it go at depth? Well, if it's inclined off like this, we'd expect to see it in borehole A. And in fact, there's a fault here with a dip of 29 degrees at an elevation of 300 meters above sea level. So let's just suggest that these two fault segments link up, and this also is fault X. Well, 300 meters in our well puts it about there at depth, but it's got a dip of 29 degrees, so let's just pop that on. There we go. So there's the fault there. So if we try and join these up, we can see this fault loses or decreases in dip downwards, something like this. So we have a fault that's curved in the plane of section, and it's curved slightly in the map view as well. So the map and cross section are consistent with one another. Now it's time to turn our attention to the next fault that we found, which I labelled fault Y, which we can locate at our crop, dipping down from the Ving in the valley in this direction, so we should encounter it in well C, and that's indeed what we find at an elevation of 1150 and with a dip of 40 degrees southwest in borehole C. So let's just plot that on. There we go. So again, this fault becomes steeper as it approaches the surface, and as it goes down, we expect to find it down in here in the deeper part of well B. I'll just call this so we know what we're doing. This is fault Y, so this becomes fault Y, and again we'd expect to see that go down there to fault Y. So we're suggesting we just draw it, sketch it through on our boreholes, that this is fault Y and this is fault X coming through, something like that. We just need to plot this now onto our profile. So there's the information compiled onto our wells. So we just need to join these up. Again, quite gently dipping it, well, almost horizontal in well A. Perhaps something like that as a listric fault going right over to almost horizontal. So there's our fault X. I'll just label it, and there's fault Y. Now let's turn our attention to putting the strata in against the faults. And we can see, let's start here in this fault block between wells A and B. And I can see that the boundary between the mudstone and the sandstone here, well, both units are dipping at 25 degrees. So we can assume the boundary between the two is also at 25 degrees. Let's just locate it, which we can get our map strip out. That was well A and B, B and C. There's well A, which we can put on. There is the boundary between mudstone, sandstone, and while we'll do it, let's compile up. There is the conglomerate, and that right on the edge there is where the edge of the mudstone is. And we can take that information and compile it onto our profile here, like this. There are our two wells, B and A. That's where the mudstone is. There's that bit of boundary there, that one there, and that the edge of the slate is just coming in at the edge there. So there are the units. So let's plot in the boundary between the sandstone and the mudstone. The dip is 25 degrees, so I'll just take my protractor into here, dipping this way. 25 degrees puts me there. Just line it all up. 25 degrees, there's the dip at the surface. So this unit comes down against the fault here. So we got a cut off in the hanging wall to the fault of the boundary between the mudstone and the sandstone. Mudstone, sandstone. Just there. Okay, well, let's put some other dips on here. And I can see that as we approach this package of conglomerate, the sandstone that lies on top is dipping at 29 degrees, but the underlying mudstone is dipping at 38 degrees, so almost 10 degrees steeper. So we'll take those two bits of information together to put them onto the profile. So I've just put little ticks to represent the dips, and if the underlying surface is dipping more steeply than the overlying, then presumably this conglomerate is actually a wedge shape. Well, let's find out where this projects in the subsurface, because we'd expect to see the top of the conglomerate intersect the well A, and indeed we do. At 800 meters down, or 800 meters elevation, we can find the top of the conglomerate. So let's just plonk that on. That's going to put it about there. So this is coming down something like that. What about the base? Well, the base is at 550, puts it there. So we can see this conglomerate is slightly wedge shaped, coming down something like that. So gradually increasing in thickness, going down towards the fault. And we can just snap these now down to the fault. Something like this. So there is our conglomerate. I'll just put some sort of conglomerate symbols in here just to see what we've got. And of course, we've also got the dips in the well of 31, so we can just confirm that these dips are more or less correct. Yeah, that's not too bad. So the dips of 31 degrees in the well is what we're seeing. Now the next thing I want to do is, rather than plot any more in this fault block, I want to try and find where this conglomerate is in the footwall to the fault, so we can get an idea of how much displacement there is on the fault at an early stage in our analysis. So what I can find in well B is that the conglomerate is directly under the fault plane. So this bit is conglomerate right down to, well, only just above 1,000 meters. So that's about there. And the dip here is 29 degrees, presumably somewhere in this direction. We can see that the dips at the surface are towards the northeast, so this dip is presumably also to the northeast. Let's just plop it on. Something like that, which just means that there's a little tiny bit of conglomerate in here, so we can see that that sits around. We can also find it at outcrop, so we'll get our map strip out again, plonk it on like this in the hanging wall, in other words the northeast side of this fault, of fault X. There is the conglomerate, the top of it at outcrop. Let's just pop this onto here, there. So that's the top of the conglomerate, dipping down at, let's say, 22 degrees, somewhere between 23 and 21. So we'll just draw that on. Something like that, move it across to in the right place. There we go. There's the dip here of the top of the conglomerate. So this is conglomerate in here. So we can see that the conglomerate's been moved down in the hanging wall to the fault. So this is a normal fault. The hanging wall's moved down relative to the footwall. Well, we might expect this conglomerate unit to intersect well C if it's projecting down like this. But in fact, we're going to intersect the fault. So if we look in well C, in fact, there's no rocks from this fault block apart from a tiny little piece of the sandstone, which is this piece here. So we've got no further information. We can therefore just project these dips in the conglomerate down something like this into the subsurface. So there's the conglomerate like this, and up in the sky. So I think what we want to do here is to just note that the offset comes down like this. I'm going to adjust this a little bit because there's quite a thickness in this, and this piece of conglomerate would originally rested on here. So I'm just going to adjust this so that we have slightly more conglomerate than I'd initially drawn, so that this piece here can sit back on this piece here. It's a detail. There we go, and there's the footwall cut off, there's the hanging wall cut off of the top of the conglomerate. Sandstone's on top, sandstone's on top. This milestone we can't find on this side of the fault. It's presumably been eroded away. Okay, so just so we know what we're doing, I'm going to colour this up. Okay, so that's the story so far. We've got our conglomerate in the hanging wall to what I've labelled fault X, found in the footwall to fault X, which is also in the hanging wall to fault Y. So we've got two normal faults which are down-throwing and rotating this conglomerate unit. So now let's put in the mudstone that underlies, and particularly the mudstone slate boundary, which we find at outcrop right at the very edge of our cross section, but we also find in well B here in the next fault block over at an elevation of 200 metres with a dip of 42. So a steeper dip in here which we can use to help us. Let's just put those on. So there's the dip of 42 for the mudstones over here, right on the edge of the cross section, and it's also at 42 degrees in the well in B. So I've just plopped those on, and so let's just project those up and snap them onto the fault. So that's coming up like that. Again, it's a wedge shape, and then this is going to project down something like this, but we need a bit more fault drawn in, something like that perhaps, for X, and let's take Y across as well. So we've got two pieces of mudstone in here. This would be slate. So let's just colour these up. So there we go. That's the slate and the mudstone coloured up, the faults continuing down into the slate over here, and the mudstone showing the same offset as the conglomerates and sandstone in here, like that. Okay, so now let's see if we can find what's going on in well C. And the only boundary in well C that we've got apart from the fault is the mudstone slate boundary at an elevation of 850 metres and a dip of 22, which would put it about here, dipping down presumably in this direction, like this. So we just snap that up to the fault. There we go. And again, I'll just take that down and we'll just colour this in so we can demonstrate the offset of these units across this fault here. So there we are, and we can still see the offset on fault X, and now see the offset on fault Y. Again, hanging wall down, it's a normal fault, just like its friend over here. Now we need to do this area on our profile. So let's get going with our map strip again, and we want to collect the information for where these units are from the map and put it on the profile. So we'll just line this all up again. Here we go. So there's that bit and that bit. That's the mudstone. That's the sandstone. That's the lateral equivalent to the conglomerate, and this is the upper sandstone, which I'll just put on like that. And we can take this information and put it across on the on here. There's our boreholes, all on. That's borehole C, fault Y, and then just move this up. There's that boundary. Just put that on carefully, and about there is where the upper sandstone is. And we can see that the upper sandstone is almost horizontal. So I'll just draw that in, like that. And indeed, the this unit in here, which is the equivalent to this conglomerate, is also essentially horizontal, isn't it? So I'm just going to put that in more or less like that. Okay, and I'll just colour this one in. I'll colour it in yellow just to make the point that it's a different fascies. So there we go. I've just coloured this in now, so that's the upper sandstone. Let's just snap it to the fault so we can just demonstrate the offset. That's going to come in like that. I'll just pop this up like this here to say that this is the fault, and let's just colour that up like that. There we go. And the key point here is that this point here in the footwall to fault Y goes down to here. The conglomerate is the lateral equivalent to the sandstone here on the hanging wall side of the fault. Finally, of course, we can put in the deeper mudstone that lies underneath in here, What we don't know is quite where it goes at depth. The dips in here are 22, which is going to be something like this coming through. So the question is, what happens down here? This is clearly an unconformity between the mudstone and the conglomerate sandstone package in here. And the final confirmation of that we can see here, because in the stratigraphic column, theoretically there should be volcanics between the mudstone and conglomerate, but they're not present, so that is an unconformity between these upper units and these deeper ones. So there's our cross section, more or less drawn in here now. The units I've not coloured up is this one here, which is the upper sandstone, which we see in these units in here. So that is that. And here is our cross section then through the map. Finally, I just want to be explicit about where some of these other units go. So even though our milestone doesn't come into outcrop, I'm just going to draw it up like this to show the offset of the milestone here and the fault that comes through like this, just so that we can show the full offset arrangements of the faults and how they downthrow the units incrementally from one fault block to the next. Let's just colour that in like this, and the upper milestone here presumably is up in the sky here somewhere, so that the fault Y comes right up like this to downthrow the upper milestone there. Something like this as we go from fault to fault across the map. So this is our final interpretation with the cross section drawn up like this, coloured up, relating the subsurface to the map pattern and the well data. It's a really neat exercise. The critical part about this is building up the story incrementally. I put the faults on first because they have to go right through the structure and the beds will be truncated by the faults. So getting the faults on early tells us how far the beds must go on the cross section. The second important point to this is building up the story fault block by fault block, so we can use the information of offsets that we get from one horizon to forecast what the other horizons are doing, and build that systematically through the map. So it's a really great exercise for building understanding and expertise of interpreting faults through strata. What we might do next is to really check that some of these offsets and patterns make sense, because there's still some freedom in how we track some of where the layers go in the subsurface, which we could use to adjust our interpretation. But that's a refinement. It wouldn't change the overall pattern. So I hope you found this exercise useful. You can find a clean copy of this exercise on the Shear Zone website, so you can have a go yourself. Have fun.